We've been working on a steel pole line 377 feeder 101 that runs between Tulsa North and Cleveland 345 subs. About a year ago, we discovered some rust holes in the poles up about 40 feet at the flange, where the top part of the pole holds onto the bottom part. Most of the poles were rusted at that spot. We went up in the bucket truck and verified that the rust was there. We contacted our superintendents and supervisors about it, and they got in touch with engineering and made them aware of the problem. Mike Herron ordered a ultrasound machine that would measure the thickness of the metal. Had a transducer on it about the size of your thumbnail or fingernail, and we just put it on there. We had to put some special coating on it to make it be able to read, and we would test. We started at structure 160 and came all the way back to Tulsa North, which was structure 1, and we just checked all them poles with that transducer. We was having to work it while it was hot. We were having to go up between the phases and in the steel basket on the Manus crane to be able to check these, and it really turned out really well. The transducer was just about flawless in its readings, so it was a slow process, but we were able to get through there, and we were able to just write if they were bad or good, which would take us from 2 poles a day. We were jump up to 6 to 8 poles a day. Just checking, because if we just got to that flange that's 40 feet off the ground and found one bad, we didn't have to go all the way to the top, because we already knew the pole was bad. So we just would move on to the next one, and we were able to speed the time up on that job. We had to rent a crane because we didn't have anything big enough to lift that amount of weight. We determined the weight to be around 11,500 pounds at 120 feet high. We just didn't have anything that could reach that high and could safely lift that weight, and keeping safety in mind. The first day that they delivered the crane, it came in 4 different pieces. The 2 tracks came together on a trailer, the counterweights came on a trailer, and the crane itself came on a trailer. The tracks alone weighed 36,000 pounds apiece. They had 60-some thousand pounds of counterweights that went on this crane, and it was pretty good architecture to put this crane together when it got down the right of way. It tells you the size of it. It really took a lot of groundwork and a lot of people to make this happen. Chester Rothammer, our boss, and Gary Cupp got together and just told me to get what I need done to get it done. Bob Bogle's crews were out there. Mike Harris was out there. They were installing gates, making crossings. A 200-ton crane just wouldn't turn on a dime. It'd run 1.5 miles an hour. When we were tracking between structures, we ended up having 3 cranes and a bucket truck out there to change these out. So we had a lot of equipment to move. There was dozer work that needed to be done. Stephen Willis's crew was out there helping us with his bucket truck. Any time a day we had 15 to 18 personnel on the right of way working on this, and we didn't need them at all times, but the times we did need them, we had to have it. The toughest part about the job was nobody in our GRDA had ever changed any of these pole sections, so it's kind of a new deal for all of us, and we had to get together and come up with a solution, and we came up with a good idea how to do it, and it worked out just fine. It was flawless, and we went way ahead of schedule. They gave us 8 weeks outage on the line to change these out, and we were done in about 2.5 to 3 weeks. Engineering's able to get some good looks at these rust spots on these poles and kind of formulate an idea and a plan of attack of what we're going to do, because we can only take this line out in the winter time.
Outages for us get submitted ahead of time. We utilize our TOA outage system. We run studies ourselves on our own contingency analysis to determine if those are going to be able to be taken out of service. Then there's a process in which we will submit that information to our reliability coordinator at SPP. They will run a contingency analysis themselves over a week-long period to determine how that's going to impact not only our system but our neighboring entities. The particular feeder that we were dealing with, feeder 101, is a 345 kV feeder that has a large amount of flow on it. Typically we can only get those out in the fall, winter, early spring time due to the high flows and the nature of getting 345 lines out of service. So we were pretty time crunched on the ability to get that line out of service. We had to make sure that each day we ended the outage in a position where we could restore the line if we needed to. So that added a little stress to the line crew in the fact that they couldn't just take things apart and then come back the next day and just pick up where they left off. Each day they would have to get the structures and everything in place to where if we needed them to, on an emergency basis, they could put that line back in service. So that added workload to them each day. Basically, they would have to set up, do a structure, maybe two, knowing that they would have to be time restricted because they were going to have to take the time at the end of the day to set it up to where we could re-energize the line if we needed to. Fortunately, we did not have to re-energize the line during the time that they had it out. We did see some contingencies that developed while the outage was there. It was ones that we had expected to see, and so we had developed mitigations with the reliability coordinator to correct those issues.